In section 4.4, we're now going to consider compound interest, which is typically how most compounding schemes work at financial institutions, whether it's mortgages or auto loans or things of that nature. When interest is computed on the principal and also any previously earned interest, it is called compound interest. When interest is calculated once each year, we say that it is compounded annually. Oftentimes, interest is computed more frequently than that. For example, if it was done twice a year, we would refer to it as semi-annually. Quarterly would be 4 times a year. Monthly would be 12, or it's even possible that the interest could be computed daily, which would be every day of the year. In order to help motivate and see how compound interest is different from simple interest, let's suppose we had the following situation. We're going to invest $5,000 for 3 years at 8%. And let's find the amount of simple interest this investment would earn. And let's also consider what would happen if the interest is compounded annually, meaning we get interest credit at the end of each year of this 3-year period. So starting off, this is what we did back in section 4.3. If we use a simple interest scheme, it's just I equals PRT. The principal is 5,000. The rate is 8%, 0.08. And for 3 years, T would be 3. We do 5,000 times 0.8 times 3. And that would give us a simple interest of $1,200. So again, if it's simple interest, it's computed once over the life of the loan, and the total interest earned would be $1,200. Now let's look at what would happen if we compute the interest according to a compound interest scheme. So because the interest is compounded annually, we need to compute the interest at the end of each year. For the first year, the interest computed would be PRT. It's 5,000 times 0.08 times 1, which means that we would earn $400 in interest at the end of the first year. Going into year 2, our principal, i.e. our starting amount, is going to be $5,400. Remember, at the very beginning of the loan, we invested $5,000. At the end of year 1, we are credited with our $400 of interest, which means that $5,400 is the amount in our account starting year 2. At the end of year 2, we will again earn interest on that amount of money according to PRT. That's our 5,400 times the rate 0.08 times that 1 year, that one additional year from year 1 to year 2. That will give us an interest amount of $432. So the amount of interest we earn in a year 2 is $432. That means that we had $5,400 starting into the account, plus we add our interest, which is $432, which means starting in year 3, the amount of money in the account should be $5,832. At the end of year 3, we'll again earn interest at the rate of 8%. So the interest earned at the end of year 3 is going to be 5,832 times 0.8 times 1, which will give us $466.56. And in total, the amount of money we'll have at the end there is going to be 5,832 plus 46,656 for a grand total of $6,289.56. Sorry, 298. 298. 629856. Let's briefly compare what is the difference in the interest we earned under a simple interest scheme as opposed to a compound interest scheme. Well, if we did the simple interest, we know that the total interest earned on the account was just $1,200. But if we look at the total interest we earned when we compounded it, we earned $400 in interest for year 1. In year 2, we earned $432 of interest. And in year 3, we earned $466.56 in interest for a total amount of interest earned of $1,298.56. So almost roughly about $100 more under the compounding interest scheme. And the reason for that is once we move beyond year 1, that amount of interest that gets credited to our account will itself continue to earn interest, which will lead to more money in our account going into the next few years. So under the compound interest scheme, the money will actually grow a lot faster. Let's see if we can kind of abstract this to make a formula. So we remember that the future amount, if it was a simple interest, was just P times 1 plus RT. What was happening every single time we were kind of finding our future amount is we had 5,000, and it was that 1 plus R if it was 1 year. In the second year, it's that previous amount times 1 plus 0.8. And then the third year, it's the same principal times 1 plus R. So we see that kind of what's happening here is that this thing is a factor that's being used a certain number of times. How many times is it being used? Well, it's being used depending upon how many years we have. So if we instead had just started with the initial principal amount, we could have multiplied this by 1 plus 0.08 raised to the third power, because it's for 3 years, and that also would have given us our final amount. Okay. Just to check this, let's make sure that this does add up. We know that we're supposed to end up with $6,298.56 in the account. If I do 5,000 times parentheses 1 plus 0.08 end parentheses, and now for some of you, depending upon what calculator you're using, we're going to start to use some exponents other than just squaring. On a TI-83 or an 84, there's this little arrow or caret key which indicates an exponent. And I can put the exponent of 3 here. And notice that that formula does give us the correct value for the compound interest after 3 years. Okay. So this brings us to our formula. Anytime you hear the phrase compound interest, or in particular, if you read the problem and they talk about compounding periods, interest is paid monthly, interest is paid quarterly, etc., that's indicating that the formula we're going to use is the compound interest formula. The variables are, a lot of them are going to be the same. A will still be the future amount. P is the principal. R is the rate, typically expressed and given as a percentage, but we need to convert it to a decimal in our formulas. T is still time in years. And the one new little wrinkle this time is now we have a number of compounding periods because it's compound interest, and that's going to be the variable N. Okay. If it's annual, N is 1. If it's biannual, then N would be 2. If it's quarterly, N is 4. And then if it's monthly, N for us would be 12. But the formula is A equals the principal times the quantity 1 plus R divided by N raised to the NT power. If you have a scientific calculator, one like a TI-83 or 84, or even like a 30X, you can enter this in the calculator as one computation. If you don't, then be very careful. You would have to follow order of operations in order to work this out. According to order of operations, the way that it would work would be parentheses first. You would do what's in the parentheses. We have addition and division, so division would come first. You would take R divided by N, get that answer, then add it to 1. That gives us our parenthesis value. You would then raise it to the exponent. So exponent's next, that's going to be N times T. So you do N times T to get your exponent. You then raise the base to that exponent. And then the last operation would be this multiplication, taking P times this factor. If you do it in steps, just be a little bit careful because you don't want to have any round off error with this. If you round any parts of this calculation, then the future value might be thrown off a little bit by a few cents, And it's important for us, especially in a financial problem, we want to make sure that we have our answer accurate to the nearest penny. Let's take a look. Suppose we want to find the interest on a $7,000 loan. Here's our keyword right now, compounded quarterly. So that lets us know that it's going to be compound interest, and quarterly would represent 4 times per year. The rate is 3%, and the time is going to be for 5 years. So the moment you recognize that you're dealing with compound interest, let's immediately go ahead and write out the formula. It's future amount A equals P times 1 plus R over N raised to the NT power. We know that our principal is 7,000. 1 plus the rate is 3%. That's 0.03 divided by 4. And then we need to raise it to the N times T. If it's 4 periods per year, if it's quarterly, that's going to be 4 times the number of years, which would be 5. Again, order of operations, if you're doing this step by step, you would do 0.03 divided by 4. That would give you 0.0075. Add it to 1. We would get 1.0075. The exponent that's going to go up here is simply 4 times 5, which is 20. Again, be very careful with this next step. If any students make a mistake, typically this is where it will occur. At this stage, there's 2 operations left. There's this multiplication, and there's this exponent. Remember, exponents first. We would need to take 1.0075, raise it to the 20th power, making sure not to round it at all there. And then we would take that value times 7,000, and that should give us our future amount. In the calculator, here's what it would look like. It's going to be 7,000 times parentheses 1 plus 0.03 divided by 4 and parenthesis raised to the, and I'm going to put it in a parenthesis just so I can look at it and know that that whole thing that's up there is my exponent. So this is what it should look like. I go ahead and hit enter. And to the nearest penny, it is going to be $8,128.29. So that's the future value of this compounded interest loan. And I like to enter them typically as one calculation, simply because I don't have to worry about round off error or writing like 9 or 10 decimal places if I do some of the in-between steps. On the exams and the assignments, what I always recommend to students when you're doing a compound interest problem is a couple things. Number 1, always write down the formula. If it's compound interest, you should immediately write down the formula that goes with it. The second thing I always like to see that can get you partial credit is at least show me that you know how to plug the numbers into the correct spot. Okay? And then once we're there, then we just need to compute the final value. Okay, so those are the 3 big things. Correct formula, the variable substituted into the correct places, and then ultimately getting the final answer. But at least show these if you want to earn some partial credit. In terms of going from the formula to the final answer, it's up to you however you want to calculate that. If you want to do it step by step and follow order of operations, that's perfectly fine. If you have a calculator that's capable of handling that all in one entry, then by all means feel free to do that as well. Now let's be a little bit careful here because we didn't technically answer the question that was asked of us. The question said to find the interest. Okay, and this is where it's a little bit different. If you remember, when we had simple interest, we had separate formulas to calculate the interest and to calculate the future value. The only formula that we have as it pertains to compound interest is the one that gives us the future value. However, as long as you know the future value, you can very easily then compute the interest. Remember, we're going to end with $8,128.29 in the account. We initially started with $7,000. So the difference between those two, that must be the interest that was added. So if we just simply take the principal, take the future amount, subtract the principal, then what's left over, that should be the interest. Again, after all, basically stating this, remember the future amount was the principal plus the interest. So if you take this formula and if you want to solve it for the interest, we find that the interest is just the future amount taking away the principal. The difference between what we end with and what we started with is that interest value. Let's take a look at one more. Let's suppose we want to find the interest on an $11,000 loan that's compounded daily. Okay. And for us, we're going to use 365 for daily. So again, we hear that buzzword compounded, or we hear a number of compounding periods, and automatically our mind should go to the compound interest formula. A equals P times 1 plus R over N raised to the N times T power. The principal is how much we invest. That's 11,000. The rate R is 5%. That's going to be 0.05. Time has to be in years. Luckily here it is 6. It's 6 for years. And our number of compounding periods, we already wrote it, is going to be 365. We go ahead and plug everything in. The future amount should be equal to 11,000 times 1 plus R over N. That's 0.05 divided by 365 raised to the N times T power. That's 365 times 6. Let's see what that gives us. $11,000 times parenthesis 1 plus 0.05 divided by 365 and parenthesis raised to the parenthesis 365 times 6, and we would come up with a value of $14,848.14. So that's going to be the future amount of our loan. That's how much money would be in the account after 6 years. Again, the question didn't say to find the future amount. What they asked us for really was the interest. To find the interest, we just take future amount, subtract the principal, and we would find that the amount of interest earned was $3,848.14.